Lesson 5.6, Inverse of a function. Our essential question. How do you find and verify the inverse of a nonlinear function? There were two problems left on the page for us to do for independent practice. Let's take a closer look at these. First, I'm being asked to consider this function. The parent function for this problem is the square root of x. And the square root of x looks something like this. We're asked to determine whether this passes the horizontal line test. So wherever I draw the line, this will pass the horizontal line test. And if it passes the horizontal line test, then we know that the inverse is a function. So now we actually just need to find the inverse. So instead of f of x, we need to write y. So this is y equals 3 times the square root of x plus 4. I need to switch the x with the y's. And then my job is to solve for y. I have a multiply 3. I divide both sides by that 3. So x divided by 3 equaling the square root of y plus 4. If I have a square root, I need to raise that square root to a second power because this exponent of a 1/2 and this exponent of a 2 multiply to 1, they 1 each other out. So I have x squared over 9 equaling y plus 4, because x to the second power is x squared. 3 to the second power is 9. Subtract 4 from each side. I have x squared divided by 9 minus 4 equaling y. So my g of x function is the function 1 over 9 x to the second power minus 4. This is my g of x function. Now let's go ahead and graph both of these functions. F of x is a square root function that has been moved left 4. So my vertex is 1, 2, 3, 4. My f of x vertex is right here. The first x value I used was -4. That is the coordinate point -4, 0. Now we're going to use our calculator to figure out the rest of the points as it goes this way, because it's a vertical stretch of 3. So we're going to do it -3, -2, -1, 0, 1, and 2. Typing -3 into my f of x calculator, I end up getting 3. -2 into my f of x, I get 4.2. -1 into my f of x, I get 5.1. 0 into my f of x, I get 6. 1 into my f of x, I get 6.7. And 2 into my f of x, I get 7.3. So let's go ahead and graph that. So this is my f of x function. So this was f of x. My g of x, to be able to graph this g of x, we're just going to switch the x and the y's. And then we're going to graph it. And this is our g of x function. We are going to make sure it is an inverse by looking at the reflection line. So inverses are reflected along this line. If I were to fold the paper along the line, I can see that these points would land on each other. Now f of x had a restricted domain by just what the square root of x is. G of x was not supposed to have a restricted domain because g of x is just a quadratic function. This was supposed to be a full u. Since it's not a full u, it's restricted, we need to restrict the domain. So domain are x values, so this is only true when x is, the last x value used for g of x was 0, and I used all these positives. So this is only true when x is greater than or equal to 0. Our last problem, we're asked to consider this function. There's a third root, so this is the third root of x. What does a third root of x look like? A third root of x, the third root of x has this general shape. And we're being asked to determine if it's an inverse. So, horizontal line test, will it pass any place more than once? It will not. So this does pass the horizontal line test. And if it passes the horizontal line test, then we know that the inverse would be a function. So now it's asking me to find the inverse. So this is an f of x. I need it as a y. So here's my y equals function. Now I need to switch my x with my y. and I need to solve for y. So I'm going to divide both sides by 3. I have x over 3 equaling the third root of y plus 1. If I have a third root, I need to raise each side to the third power, because the 1/3 root times the 3 exponent would cancel each other out because they won each other out. This would have been x to the third all over 3 to the third is 27 equals y plus 1. Subtract 1 from each side. I have x to the third divided by 27 minus 1 equals y. So what is my g of x function? My inverse function. This is a 1/27 times x to the third minus 1. Now let's go ahead and graph. This is a third root function. They have no restricted domain. So we're going to go ahead and use a table to graph f of x. So this is our table for f of x. I'm going to find a few on the left, negatives, and a few on the right, positives, to figure out the general direction of this. I know it's a vertical stretch of 3, and I know it's moved to the left. So let's go ahead and take a look at it. Negative 3 into this function would have been negative 3.7. Negative 2 into the function would have been negative 3. Negative 1 into the function is 0. 0 into the function is 3. 1 into that function is 3.7. 2 into that function is 4.3. And 3 into that function is 4.7. So let's go ahead and graph this. So this is my f of x parent function. I see that it was moved to the left 1 and it was vertically stretched 3. We are going to use the f of x graph, switch your x and y's to figure out how to graph our g of x. So what was y's is now my x's. And what was my x's are now my y's. So we're going to go ahead and graph. And I see my function looks about like this. And this is my g of x. So who is going where? Now that they've intertwined on each other, it's a little hard to see. So let's go ahead and color our f of x in blue. So this is my f of x function in blue. And we're going to color our g of x function in green. So here's my g of x function in green. And that looks right because g of x was to the third power. Cubics look like chairs. And the f of x was a cube root, and those are sideways. Now I just need to make sure that it is an inverse by looking at the reflection line. So here's me graphing my reflection line. Now I see if I were to fold on this dotted line that these lines would all line up. So yes, they are inverses of one another.